Hello everyone, welcome back to the channel. In this video we are going to look at the second problem from today's biweekly contest, and the name of the problem is minimum operations to make array equal part 2. So according to the problem statement, we'll be given two integer arrays of equal length, and along with that we'll be given an integer k, and we can perform the following operation on the first array. So the operation is that we select two indices I and j, and we increment the element at index I by k and decrement the element at index j by k. We have to perform this operation on the first array. Okay, so after performing this operation few times, we want our first array to be equal to the second array for all the indices. Our task is to return the minimum number of operations required to make both the arrays equal. We want the first array to be equal to the second array, and if it is impossible to make them equal, we have to return -1. So I hope the problem statement was clear. Now let us understand the approach with the help of some examples. So in order to understand the approach, we are going to consider these two examples given in the problem statement. So our task is to find the minimum steps required to make the first array equal to the second array. So now first let us see this first example, and k given to us is 3. It means that we can increment or decrement elements in the first array by 3 in one operation. So at each index we are going to calculate the difference between the elements of the two arrays. So the difference here is from 4 we want 1, so the difference is -3. It means that we need to subtract -3 from this element in order to get 1. Okay, now moving to the next index, we are having element 3 on both the arrays, which means that the difference will be 0. So now when we move to the next index, we are having element 1 in the first array and 7 in the second array. So the difference that we'll get is of 6. Since is 6, it means that we need to add 6. We need to add 6 to 1, and then we are going to get 7. And at last, so on calculating the difference, we are going to get -3. Now after calculating the difference for each index, so after calculating the difference for each index, what we are going to do is any negative difference can only be balanced by a positive difference, right? So if at a particular index we are subtracting something, then it means that we need its companion, and at that index we need to add the same amount. Okay, so basically we can say that we want that the sum of the negative differences, the absolute value of that should be same as the sum of the positive difference. So in this case, as you can see, the absolute value of the sum of the negative difference is 6, and sum of the positive difference is also 6. It means that it is possible to make array A equal to array B. What I mean to say is, if at a particular index we are subtracting by some amount, then we need to find its companion index where we are going to increment by the same amount. So, and how we are going to check that? We are going to see if the sum of the negative difference, if the absolute value of the sum of the negative difference is equal to the sum of the positive difference, then it means that it is possible to perform the operations, and at the end we are going to get array A equal to array B. this is all we need to check. And after calculating the difference array, what we are going to do is we need to find the minimum operations that we need to perform. So for that we can either store the negative differences, or we can store only the positive differences at a new array. So let's say I am initializing a new array net, and here I will store all the positive differences. So the positive differences are 0 and 6. Before, also we must check the following thing. We want that all the differences should be divisible by k, because at one operation we can subtract or decrement by k only. So we want that each difference should be divisible by k. If here our difference was 7, then it is not possible, because we can only increment or decrement by 3, and as 7 is not divisible by 3, we will return -1. So we will also keep checking whether a particular difference is divisible by k or not. Here we were having 6. Okay, so after that I was saying that once we have determined that it is possible to make both the arrays equal, we need to find the minimum steps, and for that we can either consider the positive differences, or we can only consider all the negative differences. We don't need to consider all the differences. So here I have separated all the positive differences, and one by one we are going to find the operations required. For that so here the only positive difference is 6. So in order to find the operations, what we are going to do is we will divide this difference by 3. On dividing we are going to get 2. We will get 2, and like this one by one we are going to find the operations required. So here the minimum operations is 2. Minimum steps required is 2. If I show you how it's 2, so first array given to us is 4, 3, 1 and 4, and k given to us is 3. In the first move I will select this index and this index. So here I will subtract by 3, and here I will add 3, and I will get what I will get is, and in the second operation, so in the second operation we are going to select these two indices, and we are going to get 1. This will remain same. Here we are going to add another 3, so we are going to get 4 plus 3 gives us 7, and at the last element we are going to subtract because we want 1. So here we are going to add 3, and here we are going to subtract 3, so we are going to get 1. So as you can see, in 2 operations we were able to get second array, we were able to make the array equal to the second array. So these were the 2 operations. Now coming to this second example, here also we are going to calculate the difference array. So here, as you can see, when we are going to sum all the negative differences to get -1 plus -4 plus -4 with -9, and if we sum all the positive difference, so positive difference is only, so as positive difference is not equal to the negative difference, we are going to return -1. It is not possible to make both. It is not possible to make the first array equal to the second array, and that's why we are going to return -1 here. Okay, so the thing is that we need to perform the operation on the first array, but as the negative differences are greater than the positive differences, we are not able to form the companions because of lack of the positive differences, and because of this reason it is not possible to make array A equal to array B. We cannot perform the given operation on the first array. That's why we will return -1. So these were the two examples, and there is one edge case also which we will see in our code. Now let us move to the coding section. So this is the code. So I have initialized this new array where I will be storing all my positive differences. The corner case which I was talking about is this: if our k is equals to 0, so here what we want is, we want our array A to be equal to array B in the beginning only, without performing any operation, because our k is 0, so subtracting or adding 0 is not going to yield any difference. So that's why if the two given arrays are not same, we will return -1, otherwise we will return 0. If the two are same, we are going to return 0, which means that we don't have to perform any operation. So after this corner case, what we are doing is, I have initialized this sum variable, and I will iterate through each index. I will calculate the difference at that index, and if firstly we will check if the absolute value of that difference is divisible by k. So that difference that we calculated should be divisible by k, because we can add or subtract by k amount only. So if it is not divisible by k, we are returning -1, right? Because in a particular operation we can either add by k or we can subtract by k at a time. Otherwise, if our difference between the two elements is greater than 0, if it is positive, we will add it to our net array, and we are going to add this difference to our sum variable. After checking all the indices, if the sum of the differences is not 0, it means that sum of the negative differences was not same as the sum of these positive differences, and that's why the sum is not equal to 0, and here we are going to return -1. If this condition is false, we are going to find the minimum number of operations. So we will iterate through all the positive differences, and we are going to divide each difference by k. It will give us the minimum, it will give us this minimum operations required to make that element in the first array equal to the element in the second array. So one by one we will iterate through all the positive differences, and we are going to calculate the operations required to make the element at the first array equal to the element at the second array. And after this we will return count, and if I submit this, so as you can see, it got accepted. So this was the approach to solve this problem, and I hope you liked the solution. If you are new to the channel, please consider subscribing and also share it with your friends and juniors. So that's all for this video. Thank you.